This is Professor Deriv Seitz. Coefficient of variation. This video shows how to calculate coefficients of variation using Microsoft Excel. A coefficient of variation is a measure of the relative spread of a data set. It allows you to compare different data sets in this relative spread way, because different data sets might have different units of measure, or they could be obviously in different locations in terms of the values and the spread. And to get a sense of how they are the same or different, there's this concept of the relative variation called the coefficient of variance. This spreadsheet has two data sets in it in the blue cells. They don't have to be the same number of items. It was just for convenience here. And there are 4 CVs calculated, 2 for each data set, one treating the data as a sample and the other treating the data as a population. Let's start over here on the left. The data for data set 1 goes from 10 to 100, going up by tens. Data set 2 has 1,000 times the value in data set 1 replicated. So every item is 1,000 times what it was over here. Back over in data set 1, in order to calculate the CV, and we're doing this for sample data here, we need X bar, the mean for the sample, and there's the average formula using the average function in Microsoft Excel. And the standard deviation for the sample, standdev.s, gives us that. And then the CV is a ratio, and its comment over here says it's a ratio of the standard deviation to the mean expressed as a percent. So we take D4 over D3, that gives us the ratio, standard deviation to the mean, and then multiply by 100 to take it out of the decimal to be a whole number percentage. For the population, the same formula there for the mean of the population. The standard deviation formula is a little different, standdev.p. For populations, you divide by the total number of items in the population, whereas for samples, you're dividing by n-1. And the CV comes out a little different than for the sample. On the right, the same calculations are present there. However, they are for this data set. And let's look at the results. The CV, treating it as a sample, is identical, and treating it as a population is identical, because proportionally, there's no difference in the variance. This one, although they're bigger and the spread is bigger, it's a scaling, so to speak, of the variance. Let's change this example a little bit. We'll go up to data set 2, the first item there. Instead of multiplying by 1,000, let's add 1,000 and then replicate that. And now we have a new data set 2 where every item is 1,000 greater than what it was over here. No longer multiplying, but adding. This is going to move it to a much larger position, and the mean is going to go up substantially, and that's going to change the relative variance. Look now over here, the CV is 2.87, whereas over here, it's unchanged from what it was, 55.05. It's a big difference now in these two data sets.